Okay, and now let's take a look at number 8. This was another one that several of you had asked me questions about. So let's go ahead and talk through it. Remember to hit pause, and trying to attempt it on your own is always a good idea. The question that you had in your homework, if we read it, says calculate the mass of 15 liters of ammonia at 27 degrees Celsius and 900 millimeters of mercury. And so step 1 that I've told you all along to do is to definitely write down the information that you're given. We see that our volume is in liters, which is what we want. However, that temperature is not in Kelvin, so let's go ahead and convert that into Kelvin. 27 plus 273 is going to give us 300 Kelvin. So that's the temperature that we're going to be using. Also notice right here, this is going to become a little bit of an issue. Based on the data that we have, we are going to be using the ideal gas law, pressure times volume equals N times R times T. Now, we understand that this right here is the number of moles, and remember your R, that universal gas constant. The state of Tennessee is going to give you two different values. It's either going to be 0.0821 or 8.31. So how do you know which one to use? Remember, the 0.0821 is referring to ATM, and the 8.31 is referring to kPa. What you have to remember is that it doesn't matter which R value you use as long as that pressure matches up. And as we can see right now, the pressure is not in either one of those units. So let's go ahead and convert the pressure as well. I really like to deal with ATM, but you could just as easily go to kPa. So let's go ahead and convert our pressure here. We know that there are 760 millimeters of mercury in 1 ATM. So I'm going to come over here and do that math. And that's going to give me 1.18 ATMs, atmospheres. So that new pressure. Now let's take all the data that we have. So we're going to do pressure, which is again 1.18 atmospheres, times our volume, which is 15.0 liters, equals N. I don't know the number of moles, and that's what I'm trying to solve, because if I can solve for moles, can I then convert that into mass? Absolutely. Our R value is the universal gas constant, and since we converted to atmospheres, we're going to use that 0.0821. And then last is to take a look at that temperature, which is in 300 Kelvin. Remember, that temperature is really important that it's in Kelvin, because that gas constant is based on the temperature, the volume, and the pressure all being in the correct units. And from here, it is simply an algebra problem. So give me just a minute, please, as I put this into my calculator, and you should also be trying to put this in your calculator as well. You all know I like to make mistakes, so let's double check here. I'm getting that the number of moles would be 0.7186, so we'll go ahead and round that to 719, and remember that is moles of ammonia, NH3. The question, however, didn't ask you for moles. The question asked you for mass. We know that mass is measured in grams. So once again, can we take the number of moles and convert that into grams based on what we did the past couple of weeks? Absolutely. We know that 1 mole of ammonia equals how many grams? Well, here comes that term that I told you wasn't going away for the rest of the semester. What value right here represents 1 mole, and that would be 17 grams. We find that because we know that nitrogen weighs 14, hydrogen weighs 1, and there's 3 of them, hence 17. And now we're going to take that 0.719 moles times the molar mass, and we are going to get roughly 12.2 grams of ammonia. Notice that I put it into 3 significant figures because all of the original given information was also in 3 significant figures.